Welcome to the lecture. Today we are going to see per unit quantities. First of all, first we will define what is per unit quantity. The per unit quantity is defined as the ratio of actual value to the base value of any quantity. Here the quantity, it may be a voltage or current or impedance or power. In general, the formula for per unit value is equal to actual value in any unit divided by base or reference value in same unit. Here, the base values can be selected arbitrarily. It may be the base values of voltage or current or impedance and power. So, the base voltage is nothing but rated voltage of the machine. Base current is nothing but rated current of the machine. If we know the base voltage and base current, we can able to determine the base impedance. The formula for base impedance is base voltage by base current. And similarly, the formula for base power is equal to base voltage into base current. So, for solving the per unit quantities, we will have some basic formulas. So, these are the formulas for solving the per unit quantities. The formula for base impedance is Z base is equal to KB base square divided by MVAB base. KB base is nothing but base kilovolt and MVAB base is nothing but base MVA. Similarly, for per unit reactance, that is X per unit is equal to actual reactance by base reactance. So, this per unit value we can define it for voltage, current and power. If it is for voltage, that is actual voltage by base voltage. If it is for current, that is actual current by base current. Similarly, for power, that is actual power by base power. Now, if you know the base kV and base MVA, we can able to determine the base current. So, the formula for base current is I base is equal to MVA base divided by root 3 kV base. So, for determining the actual reactance, the formula is X equal to 2 pi F L. Here, in power system, we'll have a different components. All the components are working with a different voltage level. So that we have to go for voltage conversion. So here the voltage conversions for different base voltages, we can go based on the transformer rating. So that one for converting from one base to another base, here we are using the formula kV base 2 equal to kV base 1 into kV rated 2 divided by kV rated 1. That is, rated 2 is nothing but either it may be a high voltage side or low voltage side. So, depending upon the transformer connections and depending upon the load or generator connected on the low voltage or high voltage side, we have to go for the change in base conversion. At last, we are using the formula for determining the per unit conversion from old base to new base. That is, X per unit new is equal to X per unit old into KVB old divided by KVB new the whole square into MVAB new divided by MVAB old. So, while solving the per unit calculations in a power system problem, whatever the values, that is voltage, power and reactance for the component, that values we can take it as the old values. Here we are going to convert the given value to the new common base value. That common base value either they may given in the problem or they may ask us to take any one component as a base component. For that we will see one example. So the example for per unit quantity, here we will take a single phase transformer. So if you calculate the per unit reactance for transformer either on primary side or secondary side, if you take, we will for both sides, we will get the same reactance value. So in order to justify that, here we will take one small example. Now let us see the example. A single phase transformer is rated 110 bar 440 volt 4 kVA having leakage reactance at low tension side is 0.2 ohm. Determine the leakage reactance in per unit. Here, the base value they have given it as low voltage side, so that whatever the transformer primary side voltage, that you have to take it as the base value. So the primary rated voltage is 110 volts. So that should be taken as the base voltage. So the base voltage is equal to 110 volt and the base MVA is 4 kVA. And the actual reactance value is 0.2. Based on this given value, now we have to determine the base impedance. So Z base is equal to KVB square divided by MVAB. But in our problem, they have given the voltage in terms of 110 volt and 440 volt, not in kV. You have to convert that voltage into kilowatt. Similarly, the power rating they are given in kVA, not in MVA. That also you have to convert. So that in this formula, we have to substitute the value in terms of kilovolt and MVA. So that we are converting the voltage into kilovolt. That is 110 into 10 power minus 3. And for MVA, we are converting into 4 kV into 4 MVA, that is 110 into 10 power minus 3 the whole square into 1000 divided by 4. So if you simplify this, we will get 3.025 ohm. Now we know the actual impedance. So formula for per unit impedance is actual impedance by base impedance. So the actual value is 0.2 ohm and the base impedance is 3.025 ohm. So that if you solve this, we will get 0.0661 per unit. So this is the per unit reactance for primary side. Similarly, we can convert those impedance from primary to secondary. The same we can determine the per unit reactance for secondary side also. So for secondary side, here we are going to convert the impedance from primary side to secondary side by using this formula. Z1 dash is equal to Z1 into N2 by N1 whole square, where N1 and N2 is nothing but number of turns on the primary and secondary side. So here we don't have the number of turns, but we can directly relate it to the voltage by using the transformer turns ratio. So N2 by N1 is equal to V2 by V1. So that in the place of N2 by N1, we are going to substitute the values of secondary side voltage and primary side voltage. So the primary side impedance is 0.2 and the secondary side voltage is 440 volt. Primary side voltage is 110. So the new impedance is Z1 dash is equal to 0.2 into 440 divided by 110 the whole square. So if you simplify these values, we will get 3.2 ohm. Now we can get the new actual impedance on the secondary side. Already we have determined the base impedance. So that uh, base impedance for primary side. The similar way we have to determine the base impedance for secondary side based on the secondary side voltage. So ZB is equal to 440 into 10 power minus 3 the whole square into 1000 divided by 4. If you simplify this value, the base impedance become 48.4 ohm. Now the actual value on the secondary side is 3.2 and the base impedance become 48.4. So if you divided this two value, again the per unit reactance on the secondary side become 0.0661 per unit. Now here for the primary side, we will get 0.0661 per unit and for secondary side, again we will get 0.0661 per unit. It proves that the per unit reactance value on either side of the transformer will be same. Now we will see advantages of per unit system. So when we go for a per unit system, each component will work on different voltage level. So that in per unit, we will convert all the component into common base value. So that it simplifies the power system calculations. When we go for the transformer, the impedance remains same for both sides, either primary side or secondary side. Then it reduces the numerical complexity. Next, it enables easy comparison of equipment. And last, it eliminates the repeated impedance conversions. Similarly, we will see the disadvantages of per unit system. While coming to the disadvantages, first we have to select the proper base. So if you not select the proper base, then it leads to error. Then we have to go for the voltage conversion for different components. So that need conversion between actual value and per unit values. Now, if you calculate the per unit values without selecting the proper base value, then the values which we are getting while calculating the reactance, that will not be meaningful. At last, it will be applicable only for power system studies. Thank you.